So, okay, today we're going to discuss Module 12 of Engineering Physics, and we're going to discuss the topic electricity. Okay, so when we talk about electricity, this would now pertain to charges at rest and in motion. Thus, there will be two types of electricity. The first type, as we have discussed in the previous module, which is electrostatic, or the study of charges at rest. So, particles now are charged mechanically. The second one is now through the study of your electric current, which is simply, or could also be called simply as current. This is now defined as electricity that is produced from the movement or flow of the charges. So there are two types of electric current. We have your DC or direct current, and the other one is our AC or alternating current. So what is now the difference between the two, DC and AC? So for direct current, so from the name itself, direct, so it means that the flow of charge is in one direction only. Okay? So that is between 2 points. And then for alternating current, the flow of our charge now can be alternate. So pwede siya in either directions. Okay? So examples of, or these two now, for your electric current, we will have two. These are measured now in amperes or simply as A. Okay? So example of your direct current, this will now include your cells or batteries. So yung any that would have a positive or negative on it, so it's a direct current. And then we have your alternating current, which is an example are the power plants, generators, and main supplies of your house. So for electric current, basically, for the direction of flow, for analysis, or in our computations, we follow the conventional flow. Though there is also what we call the actual or electron flow of your current. So what's the difference between conventional and actual flow? So for conventional flow of current, so if we have here our conductor, so we have your negative and your positive. So as we have learned from electrostatic, ang gumagalaw lang sa atin is the electrons. Okay? So, yung electrons natin, sila lang yung gumagalaw. So from negative, it will move to the positive direction. So the electron flow is negative to positive, but for conventional flow, we are assuming that the current is moving from positive to negative. Well, for actual electron flow, ang sinusundan is the electron flow. So if we have here your conductor, so we have positive, negative. So we already know that the negative electrons will move from negative to positive. So that is our electron flow, negative to positive. So ang actual talaga na direction of flow is from or of the current is negative to positive. So this is the actual current. But in some cases, in some analysis, we do follow the conventional. Okay? So electron flow for both will be negative to positive, but for conventional, the current flow is from positive to negative, but the actual is negative to positive. Okay? So as we have stated already, electric current is simply the flow of our charges. Or this can also be defined as the rate of flow of your electric charge. So in that case, it is now the flow of charge with respect to time. So our current now, I, can be computed as the charge, electric charge Q, divided by the time it passes. Okay, so I is your current measured in amperes, T is your time it travels or it flows in seconds, and Q is your total flow charge in coulombs. So if we know the number of electrons passing in our conductor, you can compute it using N times the charge of electron. Okay? So always remember this value. So another definition of electric current is that it is in relation to the drift velocity of the charges, how fast the charges moves in a conductor. So if we have here a segment of our conductor, so electron flows from negative to positive. So what we are going to do is that we consider now these 2 points, okay, as our change in position. So we have here your x. So from motion, we know that it is equal to the speed times the time, or the drift velocity times the time it would take to pass our x distance. Okay, so with that, we can now solve for our current as Q of the electrons yung nagmo-move, so QE times the N AVD. So for these variables, so VD is your drift velocity in the direction of a magnetic field. N is our free electron density, or your conduction electricity, which is now in meter raised to negative 3. And this is simply defined as the concentration of particles in a section. So how many or how dense our area is with electrons. Okay, so it's the number of carriers per unit volume. So it could also be computed as the number of electrons divided by the volume. So we have here your area times the x distance. Okay, so we have your A, which is the cross-sectional area of your conductor, so it should be in meters squared. So with that, you can now solve for this one. So electric current in relation to the drift velocity of charges. Okay, so take note, if we have now, so pag binigay yung NQ, that is simply your carrier charge density, or the density of the total density of your charge. So another way to define or compute our electric current is by the current density in a conductor denoted by G. So the current density is simply our current with respect to, or divided by, the cross-sectional area of the conductor. So mathematically speaking, we could write the equation as J equal to I divided by A. Okay, so that is now in amperes per meter squared. So if we're going to relate now your cross-sectional area or your current density to our equation in relation to the drift velocity, which is equal to, so from our drift velocity, so I is equal to QE NA V. So if I'm going to substitute this one in our current density equation, so we'll have to cancel out our area. So thus, J, or your current density, could also be computed simply as N times Q times V, which is your vector current density. Okay? So another way to define our electric current is as the ratio of your voltage and your resistance, which is taken from your Ohm's law, which states that our current is directly proportional to the voltage and is inversely proportional to the resistance. Okay? So from these equations, we can now have a mnemonic for your current equations. So if you think that this will be helpful for you to remember the equations, then you may use them. Okay? So we have this. I can have beer and eat barbecue with Gia. So saan nanggaling yan? So I can have is taken from your equation in relation to drift velocity. I is equal to Q and AV. Then we have beer is from your Ohm's law. V is equal to IR. And eat barbecue is taken from the rate of flow charges. IT is equal to Q. And Gia is from your current density, which is J equal to I divided by P. Okay, so these are our equations for current. So next, so another concept that we need to learn or understand under electricity is resistivity and resistance. So when we talk about resistivity or the rho, okay, rho, we define this as the quantitative measure of your material's opposition to flow of current. So how much that does it resist the flow of your or current flow or the flow of your charges. So for this is now an intrinsic property of material which is dependent on your chemical composition and the temperature, given that the temperature is constant. So basically, ang gusto niya sabihin that the resistivity is dependent on the material of your conductor and the temperature of your conductor while your current is flowing. So a good conductor will have small resistivity, while for a good insulator, it will have a very large resistivity. So if you could remember from our heat discussions, when we say insulators, they are not good at absorbing heat. So parang ganun din. So ibig sabihin, dahil hindi nila kayang mag-absorb ng heat, mas malaki ngayon yung resistance nila sa flow of charge. While for conductors naman, they could carry or transfer heat very well. Thus, because of that property, they also have a very small resistivity to flow of current or current flow. Okay? So, conductors will have small resistivity and could transfer heat very well, while for insulators, they will have large resistivity or high resistivity to current and would not transfer heat that way. Okay? So, in that manner, resistivity now can be computed simply as ρ2 is equal to ρ1 multiplied to 1 plus alpha times T2 minus T1. Okay? So, for ρ1 and ρ2, these are now the resistivity of your conductor at temperatures 1 and temperatures 2 respectively. And alpha is now your thermal or temperature coefficient of the conductor, which is dependent on the material. And rho will be the reciprocal of your conductivity, which is now equal to 1 over sigma. So sigma is your conductivity for conductors. So still under resistivity and resistance, we have your resistance or R. So for resistance, this is now the hindrance offered by a material or a conductor in the flow of current through it. Okay? So this is now an extrinsic property of the material, which is now dependent on the amount of material, meaning the shape and the size of your material. So for resistance, this can now be computed as your rho times L divided by A. So again, rho is your resistivity. Okay? So since resistivity is constant for a certain material, so the resistance now of a material will be directly proportional to the length and is inversely proportional to the area. Okay? So, with that, we could substitute now or combine our resistance and resistivity with the equation R2 equal to R1 plus 1 or plus alpha times T2 minus T1. Okay? So, same din lang siya doon sa kanina. Yung sa kanina, rho ang ginamit, dito, resistance ang ginamit. Okay? So, since magka-cancel out lang naman yung length saka area natin, since same conductor ang pinag-uusapan natin, change lang ng temperature ang magkukos sa change ng resistance. Okay? And the resistivity. So, R1 and R2 is the resistance at temperature 1. R2 is your resistance at temperature 2. Okay? So, we'll have difference in temperature. So, alpha again is your coefficient of thermal or thermal coefficient. Rho is your resistivity. Okay? So, another concept you need to understand for electricity is your electromotive force or EMF. Okay? So, EMF o kaya yung epsilon. So, what is EMF? This is now defined as the maximum potential difference between two electrodes of a galvanic or voltaic cell. So, when we say galvanic or voltaic cell, pinaka-example natin dyan is yung battery cell ninyo, yung mga AA, AAA na batteries. Okay? So, this is now defined as the energy per unit electric charge that is imported by an energy source or by an electrical source. So, in this case, so we have here your power source, energy source, EMF, E. We have here the internal resistance of the battery, okay? And then we have here your external resistance, okay? So, let's take note of that. We have, this is our cell, okay? Yung E saka R. This one is our internal resistance. This one is our external resistance. So, with that, we could write that the EMF is equal to, when we have your current, okay, is equal to the current flow times the resistance or the sum of your internal and external resistance. So, this is taken from your Ohm's law. So, if we're going to distribute your current, I times R is equal to the voltage plus I times your internal resistance. Okay? So, this is when our source is being discharged, meaning it is moving from negative to positive. Okay? So paano siya naging negative, positive? So, this is negative, this is positive. So, the current is moving in this direction. So, negative, positive. So, pag discharging, it is V plus IR. Okay? So, if we have this case, the current now is moving from the positive to the negative, then our EMF now is written as I times R minus the internal resistance. So this one now is when our electromotive force is charging. Okay? So pag, again, discharging, it is A plus. And if it is discharging or it is charging, it is a minus. Okay? So basically, for our EMF, that is simply equal to V plus or minus I times your internal resistance. So, positive is discharging, meaning negative to positive, minus pag charging. It is negative, this is positive to negative. So, tandaan nyo lang kung saan papunta yung current, yun yung magiging sign ninyo. So, papuntang positive, kaya plus, ito, papuntang negative, kaya minus. Okay? So we have defined that current may also be computed with respect to the resistance and the voltage in a circuit or in a cell. So we have our Ohm's law. So Ohm's law now is named after physicist George Simon Ohm. And under this law, it would simply state that the voltage across a resistor is directly proportional to the current which is flowing through that resistor. So we could write now that V, or your voltage, is directly proportional to I. Okay? So to write this, we now input a proportionality constant, which is the resistance of our resistor. So in that case, we could write now the equation V is equal to IR. Okay? So also, with the power that is dissipated by your resistor, we could also get the equation P is equal to V times I. So V times I will now be also can be, or the power now can also be computed as I squared times R equal to V squared divided by R. Okay? So with our discussion of current, resistance, and your power source or your voltages or your EMFs, we can now create what we call an electric circuit or simply a circuit. So this electric circuit now is defined as closed loops or path that would form your network of components wherein our electrons or our charges will be able to flow. So for our circuits, we could now form it through different connections of our resistors. So we have the first one, which is our series connections. So from the name itself, series, ibig niyang sabihin, the resistors now are connected one after the other. Okay, so two or more elements or two or more of our resistors now would share a single node and would carry the same current. Okay, so this is now an example of a series connections. As you can see, you have here three resistors, so they would be connected continuously and they would share a common node. So this is the shared node between R1 and R2. This is the shared node between R2 and R3. Okay? So, in that case now, with respect to our resistance, our current, and our voltage, for a series connection, the current now for all of our resistances will be equivalent to each other. So, it's constant. Okay? So, the same current would also be the same value that would pass in our source or our voltage. Okay, so this is our source or your voltage. And for our resistance, the equivalent resistance now can be computed as the summation of your individual resistances. And so we have here the equation. The equivalent resistance or the total resistance could be computed as R1 plus R2 until the nth resistor. And lastly, for your voltage, V, the total voltage now is equal to the sum of your voltages. Okay, so V1 plus V2 plus the nth voltage. So, ibig sabihin nun, yung total voltage ko is equal to the voltage across R1 plus the voltage across R2 and the voltage across R3. Okay? So another way of connecting our resistors is by connecting it in parallel connection. So when we say parallel connection, ibig sabihin, we have two or more nodes or two or more resistance or components that would share the same node. And with this, they would also share the same value or magnitude of voltage across them. So an example of a parallel connection will look like this one. So as you can see, they are parallel if they have two common nodes on them. So as you can see, for R1, R2, and R3, they have a common point at this point and another common node at this point. So they are now in parallel connection. Okay? So if they only have one common node, then it's in series connection. If they have two nodes, sharing two nodes, then it's in parallel connection. So in this regards, in terms now of our resistance, your current and your voltage, for parallel connection, we could now say that an circuit or resistors that are connected in parallel would have voltages that have equal values. So meaning, we'll have the total voltage, so the total voltage or equivalent voltage is equivalent to the individual voltages of your resistance. And then also under parallel connection, the reciprocal now of your total or your equivalent resistance is equal to the sum of the reciprocals of your individual resistances. Okay? So, kunin nyo muna yung reciprocal of each resistors before you add them. You do not add the resistors and then you take the reciprocal. That's not correct. Okay? So, in this manner, for our resistors, if we have two resistors lang, so for circuits having two resistors, your equivalent resistance now can be written as 1 over R total is equal to R1 plus R2 divided by R1 times R2. Okay? Or simply, your equivalent resistance is equal now to R1 R2 over R1 plus R2. So you could memorize this or you could simply use this equation. So any will do. But basically, this equation now just came from this one. Okay? So we have already your voltage, your resistor or your resistance. So next we have our current. So in this case, the current now will be, as you can see from the figure, we have here a single current, and once it passes through the common node, it is divided into 3. So therefore, the total current or your equivalent current for a connection in parallel is equal to the sum of the individual currents. Okay? So that's for series and parallel connections. So, pwede din naman mangyari, it's a combination of series and parallel connections. So, you'll have to apply both series and parallel equations. Okay? Okay, that's it for the concepts of electricity. So, thank you for listening. We'll have another video for the problems and examples of electricity.